Alrighty, kids, in this video, we are talking about how we solve polynomial inequalities. Okay, inequalities. So we're asking, when is it greater than 0? When is it less than 0? All right, we're going to answer all of those questions. And always, the answer to an inequality is an interval. Okay, is an interval. So our answers are going to be intervals, right? They're going to have parentheses potentially. They're going to have brackets potentially. So we're going to write our answers as intervals. So we start off by telling you that here is this wonderful polynomial, right? This is a cubic, and the graph is right here. Okay, so that's the graph of our cubic. So we're not going to factor it just yet, but we're going to look at the graph and we're going to answer these questions. Okay, so if we are looking for, or if we are being asked, when is f of x equal to 0, what is it that we are finding from our graph? Where the graph crosses the x-axis. What are the x values where the graph crosses the x-axis? And that happens at -3, at 0, and at +2. Okay, so if we're talking about where is it equal, right, that's not an interval, but that's a single x value. Okay, it only crosses at one single solitary point. It does not cross at an interval. But all these other ones, well, those are intervals. So what am I trying to find if it's greater than 0? Where is my graph? We're trying to find when is the graph strictly above the x-axis. So if we're looking for strictly greater than, our answers are going to have parentheses. Okay, so it looks like it's above the x-axis from -3 to 0, right? That's the first interval. And then again from +2 on to forever, right, which is an infinity. So strictly above the x-axis, right, not on the x-axis, just above it, which is why we have a parenthesis for our interval, because parentheses mean not equal to, but this is the number where we start. Okay, the next one says, when is f of x less than 0? So where are we looking for less than? Below or under the x-axis, right? All of these things are about the x-axis, because that's where the y values are negative when your graph is below the x-axis. So that happens all the way up until -3. So from -infinity to -3 with a parenthesis, and then again the graph is below the x-axis from 0 to 2. Right? Because the y values are negative, that's where our graph is below the x-axis. Okay, where your y values are positive, that's where the graph is above the x-axis. And then when your y value is 0, that's where it's on the x-axis, where it crosses the x-axis. So then how is our problem going to look differently if we have an or equal to? Okay, above and on, which means our answers are going to have brackets. Okay, that's the only thing that changes about our answer, is now we have brackets. So greater than or equal to 0 is bracket from -3 to 0 bracket, because it's equal to 0 at both of those places. And then again, from 2 bracket to infinity, parenthesis. Right? Your infinities will always have parentheses, but because it says equal to, now we have brackets making our interval rather than parentheses. Okay, and a similar thing for below, less than, or equal to, is we're going to have brackets also, except for infinity. Infinities always get parentheses. Okay, so hopefully that's a good refresher from something we've talked about before, where your y values are above, below, or on the x-axis, right? Greater than, less than, or equal to 0. So the rest of this lesson is about how we find these intervals without a graph. Okay, so here are your steps, right? There are 4 steps. 1, 2, 3, 4. Of course, they're on the page. So let's actually do those steps so that we can get it into your brains. Okay, now what we are looking for is we are looking for the answers without a graph. So let's look at what we're being asked to find. We are being asked to find when this polynomial is greater than or equal to 0. So if we were thinking about our graph, what does that mean graphically to be greater than or equal to 0? On or above the x-axis. Okay, when is your graph on or above the x-axis? So let's talk about the y values. What is the sign of the y values if our thing is positive? Right, greater than 0. What kind of signs are greater than 0? Right, above the x-axis, but what about the sign? Are they positive, are they negative, or are they something else? Positive. So we are looking for an interval where your y values are positive. Or 0, right? Greater than or equal to 0. All the places where our graph, our y values are positive. So in order to figure out the positivity, we're going to do something called a sign analysis. A sign analysis, where we're just looking at, is it positive on this interval? Is it negative on this interval? Okay, so in order to do that, we need to make up some intervals. So here's how we make the intervals. We're going to solve this by factoring. That's why we spent all the time yesterday factoring, so we can use that factoring today. So x cubed, x squared, and minus 6x all have what in common? And x. So we factor out that common x. So we have x squared plus x minus 6 left as my quadratic. Okay, and there's lots of ways that we factor quadratics, but the basic thought goes, what numbers multiply to give us negative 6 and add to give negative or positive 1. And those two numbers become our factors. So x plus 3 and x minus 2. Okay, so we do the factoring so that we can find out your zeros, right? When is our graph equal to 0? So to do that, we do one more step, and that is set each of your factors equal to 0 and solve if necessary. Right? And I say if necessary because do you have to solve x equals 0? No, that's done, right? X equals 0. 0 is one of the places where your graph crosses the x-axis. Our other place is negative 3, and our last place is positive 2. Okay, so we have 3 zeros. There are 3 places where our cubic crosses the x-axis. So now we take your 3 zeros and we make a number line. So you draw a horizontal line, right? A long horizontal line, because we are creating intervals. So which of these 3 numbers, 0, negative 3, or 2, goes on the left of the number line? Negative 3. So negative 3 goes first, and then 0, and then 2. Okay, so we just created some intervals. Right? We created the interval everything less than negative 3. We made the interval everything between negative 3 and 0. We made the interval between 0 and 2. And our last interval is everything greater than 2. Right? So we have 4 different intervals that we're going to see. Is our graph positive or is our graph negative on that interval? So what we do is you pick a number less than negative 3 and we evaluate it. But whatever your favorite number is less than negative 3, let's just go with negative 4. That's a pretty close one. But negative 5 also works. So does negative 6, 7, 8, 9, and 45. And what we're going to do is we're going to plug negative 4 into this equation. And we're going to ask, is this positive or negative? Okay, is it positive or negative? We're going to do our sign analysis. So let's see, we have negative 4 times negative 4 plus 3 times negative 4 minus 2. Okay, yeah, your paper is kind of small, so if you can write as teeny tiny as you possibly can to get this in there. Right? And you can do this in your head eventually, I'm sure, that your brains work good enough that you can do this in your head. Because what I really want to know is the sign. Right? This is a number when I multiply these three things together, but what is the sign of that number? Is it a positive number or a negative number? So let's see, this is a negative 4, which means we have a negative. Negative 3, or negative 4 plus 3 is also a negative. Negative 4 minus 2 is also a negative. So what do I get when I do a negative times a negative times a negative? I get a negative number, right? I don't know what negative number that is, but I know it's negative. Okay? Everything to the left of negative 3 is going to give me a negative y value. So is that part of my solution? No, because I want everything positive. I want positive or equal to 0. So this is not a part of my solution. So now we check in between negative 3 and 0. So we pick any number. I guess there's only two numbers between negative 3 and 0 that we want to pick, right? Whole integers to make the math easy. And once again, we go into this equation, right? The full-on equation. So this is a negative 1, so that's a negative number. Negative 1 plus 3 is a positive number. Negative 1 minus 2 is a negative number. So what do I get when I do a negative times a positive times a negative? I get a positive number. A negative times a negative is a positive. A negative times a negative is a positive number. So between negative 3 and 0, I have positive numbers, which is exactly what I want for my answer. So this is one interval where that graph is greater than or equal to 0, right? Equal at negative 3 and 0. So I have brackets, and then it's positive in between negative 3 and 0. Because a negative times a negative is a positive. Okay? Now let's check between 0 and 2. What number would you like to use? How about positive 1? So once again, we plug positive 1 into all the places in that equation. So I get a positive number. 1 plus 3 is positive. 1 minus 2 is negative. So a positive times a negative is a negative. So in between 0 and 2, we also get negative numbers. The graph is below the x-axis. So that's not part of my solution interval. And then lastly, I'm going to pick a number greater than 2, right, to test my last interval, and I plug it into my equation. So I have a positive, and I have a positive, which means everything to the right of 2 is going to be a positive value. Okay? All I am looking for are positives and negatives. So everything from 2 on over to infinity is going to be positive. Okay, so now I can write down my answer, my solution to where my graph is greater than or equal to 0 is from negative 3 to 0, and then again from 2 to positive infinity. Okay, so our answer to an inequality is an interval. Okay, all of the places where the graph is positive. But we're only using one number to check. Okay, only use one number in that interval to check because it represents the whole entire thing. Okay, so remember, this equation is the same as that graph. Are my answers the same? Yes, they are, right? The answer from number 4, when f of x is greater than or equal to 0, is the same as my answer that I got algebraically. Okay? So you're only going to be given an equation, not a graph. Right? The graph is there to verify, but the equation and the algebra is what we're trying to get at. Okay? Let's look at the back side. So for those following along here with the worksheet, this is the bottom half of the worksheet, right? The top half has the same thing as the other side did. So we're just looking at this equation because I want to solidify the math, right? The analysis part of our problem. So here we're looking for when is this polynomial less than 0. Okay, so what kind of y values are we looking for if we want less than 0? Negative y values. We want intervals where our graphs are negative. Intervals of negative numbers. Okay, that's what less than means. Less than 0 means that we have negative y values. So when we do our sign analysis on your number line, we're looking for all the places where we have negative numbers. Okay, so we start by factoring. We always factor to solve. And what method would you use to factor this polynomial? We would factor by grouping. Very good job, grouping. So we're going to put parentheses around the first two things and parentheses around the second two things. Now, because both things have a negative, we're going to factor out the negative. Okay, negative x squared is going to be your common factor. They both have a negative, so we pull the negative out. X plus 3 is left on the inside. Anytime your first term, your leading coefficient has a minus, we're going to factor the minus out and change the sign of the second thing. Okay? And then plus 2x and 6 have a 2 as a common multiplier, leaving me with just another x plus 3. And then we have two of the same, right? We have an x plus 3 and an x plus 3. So these ones combine to give us one factor. And then we have a minus x squared and a plus 2. Okay, so if you don't mind, I'm going to write this as 2 minus x squared rather than negative x squared plus 2. Okay, a 2 minus x squared. And it's okay if you wrote negative x squared plus 2. It just looks funny when we're going to factor this any further. Okay, so those are your, those are your factors. Okay, done. So now let's solve. To solve, we take your factors and we set them equal to 0. Okay, so we take x plus 3, set it equal to 0. Take your 2 minus x squared, set it equal to 0. So x equals negative 3. Or let's add x squared to both sides. 2 equals x squared. I guess you could subtract the 2 and divide by negative 1 if you want to. But we can do it with one step just by adding x squared to the right. And then we solve by square rooting. Now, we have to remember, when you're solving by square rooting, we get positive values and negative values. When you solve by square rooting, you get positive and negative every time, whether they're whole numbers or whether they are radicals, like in this case. So now that we have your solutions, we make a number line. And you put your numbers on there. And then we put your zeros on our number line, right? So now we've made some intervals. We have everything less than negative 3. We have between negative 3 and negative root 2. We have between negative root 2 and positive root 2. And we have everything to the right of positive root 2. Okay, so pick some numbers on that interval, plug them into this factored form, and see if we get positive numbers or negative numbers. So there's our analysis, right, when we plug it in. We notice that it's positive to the left of negative 3, so that's not part of our solution. Okay, we notice that it's negative between negative 3 and negative root 2. Right, so this is part of our solution, and because it's strictly less than, we use parentheses. Right? It's positive between there, so that's not part, and then it's negative again after positive root 2. Okay, so our answer, written as an interval, is from -3 to -2. and then combined with positive root 2 to infinity. That is the interval where our equation will be negative, where the y values will be negative. Okay? That's what we're going for, is being able to take an equation, right, solve and factor it so we can make some intervals. Right? So we're using our zeros to chop up your graph into intervals, and then we're doing a sign analysis. Is it positive on this interval or is it negative on that interval? Okay, and that's how we do these kind of, oh, that's not marked. I want to do this. That's how we write the solutions. Okay, hopefully that helps you get better at these today.